Assalamualaikum warahmatullahi wabarakatuh. My name is Munirah binti Murad and my matron number is CE240199. The following code solves a first order differential equation symbolically using MATLAB. It declares y as a symbolic function of x. The first differential equation div in bracket yx equal to 3 y minus x power of 2y provides a relationship between the derivative of y with respect to x versus y and x. It used the function dsolve to solve this equation in general, then shows the result to the user. It then defines another differential equation div in bracket yx equal to y multiply 3 minus x power of 2 and solves it, giving the initial condition of y in bracket 0 equal to 2, implying that the solution should satisfy y equal to 2 and x equal to 0. Finally, it shows this particular solution once satisfying the initial condition. The above code first calculates the general solution of a differential equation and then determines the particular solutions. The following program in MATLAB will tell whether a given first order partial differential equation is exact or not. First of all, it defines symbolic variable x and y, thus they can represent the unknowns in an equation. If then defines two functions m equal to m in bracket xy and n equal to n in bracket xy, with m being the coefficient of dx and n is the coefficient of dy in the differential equation. It checks the exactness condition, that is, for the equation to be exact, the partial derivative of m with respect to y should be equal to the partial derivative of n, right, x. The code here calculates these derivatives by using MATLAB's diff function and then compares them. It gives a check whether the difference between the two derivatives reduce to 0. If they do, then the equation is exact and it prints the equation is exact, otherwise the equation is not exact. More loosely, this just checks whether the provided differential equation is exact by evaluating and checking against. First step for the Q1C, define the symbolic variables, which is sims x, y, c, g in bracket y. Define m, x, y and n in bracket x, y. M equal to coefficient of dx, n equal to coefficient of dy. Step 1, check the exactness condition, which is div m in bracket y and div n in x. Display the MATLAB coefficient. After that, verify the equation is exact. If dm equal to dn respect to x, the equation is exact. If else, not, the equation is not exact. After that, integrate m with respect to x to find part of the solution. Integrate m with respect to x. After that, step 3, compute gy from n by removing term already include. Display gy, integrate gy with respect to y, and general solution ix plus gy integrate plus c constant. Step 4, use the initial condition y in bracket 1 equal to 2 to find constant, which is c. Solve the constant c value equal to solve initial condition equal to 0. Value of c, show the value of c. Step 5, final solution, substitute c into the general solution and simplify. Final particular solution is here. This is the final solution or final answer.
Assalamualaikum, nama saya Muhammad Ilham AIMAN bin GHAZALI, nombor metri CE24017. So saya akan explain untuk soalan 2A1. Untuk step pertama, define the non-homogeneous term and define derivative. So ini adalah contoh untuk define the non-homogeneous term and define derivative. Untuk step kedua pula, define the full second order differential equation and display this equation in the command window. Okay, this is example for define the full second order differential equation, and step 3, define the homogeneous part of the equation by setting the right hand side to 0 and solve this homogeneous equation using MATLAB dissolve function. So this example for MATLAB dissolve function. This is example for MATLAB dissolve function. And last, display the complementary function. The output will be shown in simplified general solution. So this is the output C1 exponent power of negative 3x plus C2 exponent power of 4x. Okey, seterusnya untuk soalan 2A2. Yang pertama, define symbolic variable, create symbol x, C1, C2, A and B to use in solving the equation. This is example for create symbol. Yang kedua, write the solution for the part of the equation without the right hand side. This example for equation YH equals C1 exponent power of x plus C2 exponent power of negative x. Next, define the right hand side of the differential equation and multiply by 6 to match the non-homogeneous term. Next step is make a graph for the extra part the solution. This example yp equal a multiple x multiple exponent x plus b multiple x multiple exponent negative x. Next part, find the second derivative of yp and plug it into the equation to see how it fits. Next part, solve equation to find the value of a and b that make a graph work. The example is simplify left hand side minus right hand side. The next part, replace A and B, the particle solution, with their solved value. This example for replace A and B in the particle solution. The next, add the homogeneous solution YH and the particle solution YP to get the full solution. This example for Y general equals simplify YH plus YP. The last, display the solution. The output will be show the general solution to differential equation.
My name is AHMAD and I'm now going to explain the coding for the question 2B, and I'll just make it simple and clear. As you can see, the coding right behind me is how the coding looks like. There's 3 parts for all. And then this code provides systematic approach to solve system first order linear differential equation. It begins by defining coefficient matrix A and computing to its eventually eigenvalues and eigenvectors. Then are used to construct the general solution for the homogeneous system. The eigenvectors are combined with the exponential terms involving the evaluations to form the homogeneous solution. For the non-homogeneous for the non-homogeneous system, the code proposes a Sharifah solution that accounts for terms like x or exponential negative x and in the system. By substituting the Sharifah solution into the differential equation, the unknown coefficient C, D, E and F determined by solving the resulting equation, the solution are substituted back to form the particular solution. The general solution of the system is the sum of the homogeneous and particular solution to make the solution specific. Initial conditions are applied and constant A1 and A2 are calculated by solving equation derived from substituting the initial condition into the general solution. Finally, the complete solution is displayed, which satisfies both the differential equation and given initial condition. This approach integrates symbolic computation with theoretical method. and ensuring clarity and precision in solving a linear differential system. That's for me. Thank you.
Hello everyone, my name is Tan Ming. My normal metric is CE24008. Today I will explain about question 3, ordinary differential equation project, which solve a system of differential equation by using coding in MATLAB and manual calculation. Let's begin. First of all, the question is given two equations as here. By refer to the equation, we can get that the metric A 1638. By using the metric A, substitute into the formula A minus lambda I equal to 0, we can get that the lambda value of lambda. In coding, we're using EIG function to get the value of lambda. The value of lambda 1 and lambda 2 is equal to -1 and 10. By using the H value, we can find the H vector here. The H vector we find is 2, 3 and -3, 1. After obtain two value, we can substitute the value into the general homogeneous solution YC to get the equation of YC here. And then next, the particular integral YP can be assumed by based on the component G as at here. So after form the formula based on the table, we need to compare the YP with YC. So finally we get the YP solution and here YP general solution. So based on the concept I use at the manual calculation, I will separate the YP general solution into the part just contain x times exponent of -x, and part 2 will be exponent power of -x only. This can use to simply solve the unknown C and D and E and F at the different parts. So the parts 1 can use to solve the equation C and D by differentiate the YP which contain the x times exponent power of -x, and then substitute into the equation YP prime equal to A times YP plus G. But at G here, the G is only contain exponent power of -x. So at here, I didn't put it as in the calculation. So at here, we can get that the two equation here, equation 1 and equation 2. But these two equation is actually the same, so we get the only one equation here, which is C equal to 3, -3D. So at the part 2, we do the same as the part 1. So we solve the equation here by substitute into the formula y prime equal to AYP plus F. So we get two formula here, equation 1 and equation 2. So actually these two formula is not same, so we can get the totally 3 equation here. So as equal to theory, we know that 3 equation only can find 3 unknowns. So at here, we need to assume one of the unknown equal to a number. So here I assume that f equal to 0 to find the other else unknown, C, D, E. So after substitute, this O is the substitute to find the C, D, E, F. So F value, as I assume that equal to 0, so we get that the others value C, D, E. So after that, need to substitute the unknown C, D, E, F with the value back to the YP particular integral. And then we need to find the general solution Y, which Y equal to YC plus YP, general solution, before separate. So at here we can get that there still have the unknown A1 and A2. And in this question, we get that the initial condition x equal to 0 and y equal to 1. So by solving this equation, we can get that the value A1 and A2. So as A1 equal to 34 divided by 1 to 1, A2 equal to 19 divided by 1 to 1. So substitute the A1 and A2 back to the Y formula, and we get that the Y final here.